Okay. So I hope you can hear me clearly. So what's up and welcome back once again. So today we are going to do something on AI chatbots, or if you're building RAG systems. So there's one thing that I've come across when we are working with RAG systems, and I think it's to do with ensuring that your RAG systems or chatbots are able to remember user interaction. So when you are asking questions to your chatbot, it's able to actually understand through the previous interactions, and then whatever responses that it's going to generate, it's going to be actually aligned with your with the previous interactions. Okay, so there's one thing that I came across, and that is to do with the LangChain. So let me. So LangChain, I look for it. So LangChain short-term memory. So let's see if you can get to see. So there's this long-term LangChain short-term memory. So this is a documentation from LangChain. So I think LangChain has improved quite significantly when it comes to the newer version of LangChain. I think it's quite interesting, which is an improvement from what was there previously. So there's this core component short-term memory, which I find it quite interesting. So it enables us to actually introduce a memory component in the RAG applications, chat applications that we are actually building. So the short-term memory, so memory within a system. So this helps us to actually remember information about the previous interactions. So when we enable or build or embed memory within our applications that we are building, so we are making our applications to be a little bit stateful. Stateful, that means that whenever we are trying to when the queries that you are going, the chats that you are going to be, the interactions that you're going to be making with our applications, so the model is actually able to remember, therefore tailor our subsequent responses within whatever domain that we are actually conversing about. So memory in a system, that memory is a system that actually remembers the information about the previous interaction. So that is essentially what we are trying to actually embed with the short-term memory. So for AI agents, memory is actually crucial because it lets us to actually remember the previous interactions, which is very important, learn from the feedback, and also adapt to the user preferences. Okay, so remember when you're having a conversation with your friend, your colleague, so there's that flow of conversation. Okay, so maybe you ask them a questions, they reply back based on that response. You're able to tailor make another response. Then you ask that follow up. Okay, so that interaction is quite important even in the chat applications, so that whenever we are going to have this interaction, every question does not seem like a new question. Like every question should not entail that starting the conversation all over again. Okay. So with the short-term memory, it lets the application to actually remember the previous interactions within a single thread of conversation. So whenever we're having this conversation, there is some sort of limit, or there's I can call it limit. There's some sort of that guardrails or limits to which we are conversing. This is the topic that we are conversing. Then we keep it within these bounds. Okay, so that is what having a memory actually help us be able to keep that conversation within certain limits. Okay, so conversation history is the most common form of short-term memory. The long conversations, but for the long conversations, actually pose a challenge to today's LLMs. So a full history may not fit inside the LLM's context window. Again, you might have an LLM that has this massive context window, but it does not mean that it will be accurate when it comes to remembering all types of interactions. Okay, so we need to actually find way to actually we might have the larger context window, but we need to actually find ways that will enable us to actually this is the sound. Just give me a minute. Let me see if the sound is okay. Okay. So let me see if the sound is okay. Just give me a minute. Quite important, even I think the sound is okay. So conversation history is the most common form of short-term memory. Long conversation actually pose a challenge to today's LLMs. Full history may not fit inside the LLM's context window. And again, you need to understand something. The context window might be wide, but it also comes with a challenge, especially if you're paying for the API usage of these keys. Okay, so you need to also actually check on that. So even if your model supports the full context length, most LLMs still perform poorly over long context. So we need to actually check on this. Then they get distracted by stale or off-topic content, all while suffering from slower response time and higher cost, which is very important, especially if you're going to build AI applications, especially the chat applications. Okay, so chat models accept context using messages, which include instructions. Chat models accept context using messages, which include instructions. So that is the system messages, and also an input coming from the human messages. So in chat applications, messages alternate between human inputs and the model response, resulting in a list, some type of a list of messages that actually grows over a long period of time. Now, because context windows are actually limited, many applications can benefit from using techniques to actually remove or forget stale information. So that is essentially what you're going to actually create today. So we are going to use the LangChain's short memory component. So build an application, then apply the short-term memory, so that even if we are having thousands of human input plus human messages plus the system message, we're able to trim and give the model. Let's say we are going to give a model that I just want you to remember these interactions up to this iteration, 6th iteration, 5th iteration, depending on how you want to actually do that. So it's an adjustable parameter that you can actually use for that. So usage to add short-term memory, thread level persistence to an agent, you need to specify a checkpointer. So when creating an agent, so this is just an example of or how like the documentation of how you can actually create this. Then the common pattern. So with short-term memory enabled, long conversation can exceed the LLM's context window. So common solutions to actually solve this problem is you can trim the messages. So you remove the first or the last n messages. So I think we can remove the first n messages. So n is an adjustable parameter that you can actually increase or decrease depending on the size of the chats. So then you can also decide to delete the messages. So this one deletes the messages from the LangGraph permanently. Then you can also do summarize the messages. So as you are continuing with the chatting experience, you can actually summarize with each interaction, so that instead of trimming, you can summarize, so that you are actually ensuring that, okay, because for trimming, you're going to lose track of, let's say, the first n messages, let's say the first 6 interactions, okay? Then when you are in the 8th interaction, you might refer back to what we were discussing maybe in the second interaction. So, but having the summarized messages, you're able to summarize that conversation as a rolling window, so that you're able to maintain summary of the main entities that were actually discussed during those interactions. And once you have that, and this is some sort of a rolling window, so that is another example of actually summarizing the messages. Trim, summarize, delete, and you can also have your custom strategies to actually implement such components. So this is the trim messages, the delete messages, then you have the summarization messages. So you can just summarize this so that it's from some form of a rolling window. So how to access your memory. So this is the read short-term memory in tool. Then you can write. So you can actually modify the agent's short-term memory state during the execution. So this is you can read, or you can also write. Okay. So this is what we will be building in this series. So we are going to start just with a simple build for this. Then from there, we will try to see how we can enhance this further. Okay. So let's jump to the code right then and see how we can actually implement this solution. So okay, so I need the main, so maybe later. Okay, so I'll start this by chat memory. I'll just first create a new folder. Let it be a directory. So this one will be about all our configuration details. So I'll create another file. Let's say configuration manager. This is the configuration manager. Then I'll also create another one. Let's say the database, DB. Okay. So then within this, I'll also create another file. And then I'll just call that memory. So that's the memory. Then here I'll just create a new file, and I'll name this file chat memory. So chat memory. I think that one is okay. So let's start populating this. I'm going to start with the configuration manager. So for the configuration manager, so in OS, then so this is all about our configuration details. So from .env import load.env, then I can just load it here. Then so let's create a MongoDB configuration. So MongoDB MongoDB configuration DB configuration. for the MongoDB configuration. MongoDB. So here we'll be passing in the MongoDB URI. So the reason why I'm using MongoDB is that MongoDB will act as our storage. We need to be storing these charts. Even though we'll be deleting this chart within our memory, we want to store those charts and we can use MongoDB for that. So MongoDB will be a persistent storage for our charts, but our short memory will be ephemeral. So after some interactions, those interactions can actually be deleted. So if we delete those interactions, maybe in the next session, when you're creating a new session, we want to continue the interaction, then we can go back to MongoDB and actually fetch the last conversations that we had, load that to memory, and just continue with the process. So I think that's why having a storage is actually important. So if not MongoDB URI, then we can just raise a value error. Raise a value. MongoDB URI is not it's not present or set within our. Then we can give the MongoDB. Then we can actually give DB can actually pass in the name. So we can also give the name of our. We have the collections, the database. Can give the name of the database. So os.get get env. So that is the MongoDB name, and they'll just pass in the name that I've actually created. Rag chat. So this is the name of my database in MongoDB. Then because you're going to use a large language model, so I'll use Groq API configuration. So for this one, Groq API key, then I will just pass in the Groq API key. Then we can use a conditional statement so that whenever we are missing this API key, it throws an error so that we're able to find what we are missing. So there's one thing that I actually missed, and that is we need to set up our environment and actually install the dependencies that we need. So we need to create the requirements.txt file. So the requirements.txt file. So under the requirements.txt file, we need to actually pass in our requirements. So the requirements that we will be needing in this tutorial. So we're going to use LangChain. Also going to use LangChain. We're going to use LangGraph, LangChain, Groq. So Groq will be the one that is providing us with the large language models. Also LangChain, MongoDB. That one, MongoDB. I think that one is okay. Then by Mongo. Another one will be python.env. Python.env. Then Streamlit. So we'll have a user interface. Then data.json. Even this one is important. So I think it's LangGraph checkpoint. Check checkpoint. MongoDB. Then I think those ones are okay. Then grand that one. Okay. So these are the dependencies that we'll need in this tutorial. So I'm just going to create a new environment. So I'll just create an environment. So I'll add an interpreter from the local. Then I'll use conda environment. Then short-term memory, maybe I can just move this one so that it's short-term memory, and that is be okay. And we can actually just create a new environment. So as we create our conda interpreter, this will create our virtual environment. And once we have our virtual environment, The next thing obviously will be, and you can actually just create a new. And once we have our virtual environment, the next thing obviously will be, we can actually just create a new. Okay, let's see if like using, did we, don't think we can just add a new interpreter for this so that we are not conflicting with the previous project. So just create a new short-term memory, then just create a new environment. So as we are creating this environment, so once we create a virtual environment, we'll have to actually we will need to, I think it will just be activated. We don't need to worry. Conda Thomas services. I don't know why I'm getting these. Let me try to run this. That one is okay. I was not aware of this, but I can just push forward. It's no problem. So let me try. Let me see if I can find like using Bash as my terminal. Look, version control. I can just search. I think it's here. We can go to preferences. Let me use Bash. This one will be okay for us. And now let me try to me try to use another interpreter. Just create a virtual environment. You will be getting that error again. I think this one will work. So as we are creating our virtual environment, so we can then move on. I think we can just start with the configuration. So we did the config, the virtual environment. So we are going to don't know why we're having problems. I think it's now. Just